this kind of field. It has this very nice general definition of what a group or community is, which is that it's a group of vertices that have similar group-level connectivity patterns. It's a general approach for learning large-scale patterns. You can develop these very fast methods for doing it. And importantly, the thing that I like about it is that you can extend it to learn from rich sources of data, whether they're edge weights or vertex attributes or things evolving over time, et cetera. It's a very rich model space in which to play. Applications are really unlimited here. These are a few of the things that we're doing in my group. We're looking at some brain networks. We're looking at these malaria recombination networks, social networks, and then in particular, a very general category is networks with metadata, trying to understand how we can learn from both connectivity and also the annotations on the vertexes. But there's also lots of open questions here. So how much auxiliary information can we really absorb into these models? It may be that there are some limits, that once the models become too complex, they sort of become unwieldy computationally, or they are too complicated for the kinds of data that we have access to. How do we interpret the output of these models, especially for science? That mixing matrix, I think, is the key. But if it's large, and in these applications to real data, often you find that k ends up being something like roughly square root n. That means you have order n free parameters in the matrix. That's a lot of parameters to interpret. On top of that, the colors are all exchangeable. So those pictures I showed you in the beginning of the talk of these like onion shapes and the nice order shapes, those are really nice. But imagine if I had permuted, taken a random permutation of the rows and columns, you might not have been able to see that that was the pattern there. So we still don't really know how to get the right kind of output from these models to interpret it for certain applications. And then there's a lot of questions about dynamics, right? That's what we really care about when we think about processes. What are the mechanisms that produce these edges? That's really a question about dynamics. And these models are naive in that respect. They don't learn from the kind of